Let's take a look at finding vertical asymptotes for the following function. Now, the thing about vertical asymptotes is that you need to make sure that the bottom is 0, but the top is not. And this happens in this case, but it is trickier to go ahead and factor the bottom in order to solve for zeros, right? Because vertical asymptotes, again, because you can't divide by 0, that's when you have to exclude those x values, and that's where you're going to see those vertical lines that we call asymptotes. Now, I also wanted to graph it for you so you can see how the graph breaks at some values. And it looks like here it's -8, and it looks like it's at 4. But why? Okay, so how do we know this? So what we're going to do is just try to factor the bottom. Now, because the order of terms is not the way that we used to, right? Because usually we start with the highest degree, right? Highest power. So that would be x squared, then x, then the number. So the first thing we have to do is reorder the terms. So we're going to go with -x squared first, then with -4x, and then we add 32. So again, the degree of this polynomial is going to be 2. That's like the largest power of x. How do we factor something like that? Well, you can't start yet because your leading term is negative. You can see right here, there's a minus sign. So you can't start factoring until you factor this minus out. Okay, so if I were to go ahead and factor it out, then what am I going to get? Well, here I'm going to have x squared. So you're like taking away a minus. And then this is 4x and this is 32. The trickiest part, and where students usually mess up, and I see this all the time, is that they forget when they take out a minus, they have to switch signs for all terms. Not just for the first one, but also for the second and for the third in this case. So if you were to put a minus right here, that would not be correct, because if you start distributing this minus right here and here, the minus will give you a plus, but you don't want that, right? So this is not right. So right here, we need a plus. Now, for this plus right here, this is where we wanted the opposite. So if we were to leave a plus here, if you were to start distributing the negative over here, what will happen? You'll have a -32, right? But you want plus 32. Okay, so this means that I need to get rid of this, and I need to put this as a minus. Okay, so switch signs for every term. Now we are ready to factor something like this. So we're going to leave the minus outside. We are looking for two numbers, such as their sum is 4, +4, and their product is -32. Okay, so maybe you know that 8 and 4 are multiples, right, of 32. And because the product is negative, one of them has to be negative, one of them has to be positive. Now, the sum is +4, so I think this is going to be +8 and then -4, right? Because then if you start to FOIL it, you will see x squared -4x plus 8x, which is going to give you +4x, and then -32. Okay, so that's going to be over here. That's how you factor a polynomial with a negative in the leading term. All right. Once you do that, what are the equations of the asymptotes? Another mistake is to say, okay, well, then that's just going to be x equals 8 and x equals 4. Or -4. Okay, I guess somebody could make a mistake like that. That's not right. Why? Because when you set this equals 0 and use zero factor property, you want x plus 8 to be 0, but that does not happen at +8. That happens at -8, right? Because when we subtract 8 from both sides, we will see that x equals -8 here. Okay? And then the other factor is x minus 4 equals 0. Well, we add 4 to both sides, and that happens when x equals to +4. So this should be a +4, not a -4. And again, this is confirmed by looking at the graphs. You see how at -8 we had that asymptote, and at +4 we have an asymptote, so we just confirmed it graphically also.